In this lecture, we're going to be looking at experimental research designs, including quasi-experimental and true experiments.
Now, typically, experimental research means that the independent variable can be manipulated. There's several types of these designs, but you can classify them, as I said, in two different categories, and these are true experiments and quasi-experiments. Now, in a true experiment, the researcher is actually manipulating or controlling an independent variable. Now, in the field of education, it's extremely difficult to do a true experiment. So typically what we do are quasi-experimental studies. This is where the researcher could but doesn't actually manipulate an independent variable. For example, the researcher might use existing classes rather than assigning students to a particular teaching method. So this is, sort of the convenience of using the quasi-experimental method. So there's a couple of symbols that you should be aware of when you're thinking about experimental designs. These typically are like descriptive names and diagrams. So in the diagrams, you have A, B, C, and D, and these refer to different groups of people. So it could be, different classes or different organizations or different schools, depending on what your, unit of analysis is going to be. And then you have things like X, X1, X2. So this X refers to some sort of treatment. So treatment could be a teaching method that's preferred or a type of intervention. So that's really what the treatment is in this particular case. And then O represents observation or assessment. So if you're looking at, which we'll talk about a little bit later, like single subject research, the intervention is something that you want to observe to see if, like a behavior can be reduced, for instance, or you want to see if a particular teaching method works. So you're going to observe the kids to see, how this is affecting the particular students. And then R stands for random assignment. So you're randomly assigning people to different groups. So if you have a large number of participants, this means that you're not just, like you're not conveniently placing students in a particular class or a particular teaching method. They're randomly in different teaching methods. So here's an example of this, okay? So this is a diagram for a one-group post-test only design, quasi-experimental. So you see A, X, and O. Remember again, A is the group, so A is one group, and then X is the treatment, and O is some sort of assessment. So if we give an example, say like you're looking at a fourth grade class. So the fourth grade class is A, that's the group that you're looking at. And then you're doing some sort of percentages with the group. Okay, so that's the X. The group is working on percentages. That's their treatment, right? And then this gives them a test at the end to see, how they did on that particular subject, right? So the test is O, the observation. So for these types of designs, right, the A, X, and O, this one group post-test only design, this is considered a very weak design because this treatment, right, the effect of this treatment, right, could have come from a variety of sources other than the treatment, right? So if we're looking at, this treatment of giving students like, support with percentages, right? There could be a lot of different reasons that they're doing better or worse on that particular subject, right, when you're assessing them. So, like some of them might have prepared study guides at home. Somebody might have had, parental help. Somebody might have had a tutor. There might be some accommodations, right, in the classroom. So there's a variety of influences on that particular treatment, and that's called threat to validity. So the threat to validity makes this sort of a weak design. So there's, a lot of other sources that could have caused this to happen. So now we have another example, which is the pre-test, post-test with one group. So again, that A is the group, right? And then instead of just doing an assessment afterwards, you're doing one assessment before and then another one after the treatment. So you get to compare sort of the before and after. So let's say that you have TBE students test their software this way. So like students can take a test, use a software, and then take an equivalent test. So for like, let's say you're working on a GRE or an SAT test, right? You could measure students' performance on the SAT before they're using the software to help them practice, and then after to see if their scores improve. So that's the pre-test, post-test design with one group. Now, one group designs are typically not considered very strong because they have nothing with which to compare the results, right? Yes, we have a pre-test, post-test design, but subjects are being compared to themselves and not to anybody else. So we're just seeing progress in like one group of students. So again, they're still considered not very strong. So as you can probably see, we're kind of leading into a couple of designs that may be a little stronger for those of you who are interested in using a pre-test, post-test. Now, there are quasi-experimental tests that are a little bit stronger. So there's stronger designs, which are more believable, and these are time series designs. So it's similar to the one group where they have the pre-test, post-test, but subjects are given the pre-test several times until like there's some stable results between the subjects. So subjects are scoring the same several times. So let's say with the SAT, right, we give the group of students an SAT test, let's say every weekend. And so we look across them until we see that, they're getting kind of the same score. So if they, got an 1100 the first time, they're still getting like maybe an 1120 or 1130, nothing like too radically different, like a 1400. Okay. So that would be showing that they're kind of stable across. So then you can kind of measure kind of across time is what this is showing us. So another example of this is, suppose a teacher wants to know if a new teaching method will increase the student's knowledge of fractions. So they give a pretest about fractions like several times, and at first the students may have different scores each time when they're performing in different ways, but eventually over time they're going to be getting similar scores, ideally. So as I said, like after a couple of times, this teacher notices that the students' scores are approximately the same. And then after the treatment, which is a new teaching method for fractions, let's say, the researcher gives a post-test several times as well. And this way the teacher can be more than sure that those high test scores were a result of the treatment and not just, this change in, practice or something like that. Okay? Now, it's important to know that the results are more believable when there are more comparisons. So that's typically just true in general for these quasi-experimental designs. So several groups can be involved in the study and their assessments can then be compared. So just keep in mind, if you decide to do a quantitative study and you do decide to do something quasi-experimental, the more that you can observe or assess, the more, strong your particular design will be and look. So there's a couple things we should think about with different types of groups that you use for the particular design you choose. So when there are several groups, the first group receiving the treatment is known as an experimental group. And then when the group receives a treatment different from that experimental group, it's called a comparison group. So that's the group that's being compared to. So when the group receives no treatment or no particular intervention or no particular method, this is called the control group. So control groups means like that there's nothing happening to that particular group. So the first group would be the experimental group, and then there's a comparison group. So maybe one group gets the, method A for fractions, one group gets method B for fractions, and then the third group doesn't get anything different. So that's kind of how you would do this comparison. Now, there are also what are called non-equivalent groups. So non-equivalent means that existing groups are used. There's no random assignment, so it's quasi-experimental. There's two existing groups. One receives treatment and the other doesn't, and then they both get the same test. So that's what we would call non-equivalent. Now here, for example, if we have non-equivalent groups with control group and post-test only, remember we have A here, which is our group, X is our treatment, and then O our observation. So that's for the experimental group. And then we have group B, which just has some observations, but there's no experiment or no treatment given to that group. So an example of this would be, you have two classrooms in middle school, okay? One gets music therapy for their group, and then the other does not. Their behavior then is assessed at the end of the year. So you observe their behavior, but one didn't get any music therapy. So then you kind of see whose behavior, for instance, would be better or something like that. Now, if you have a non-equivalent group, comparison group, or alternative treatment post-test only, this is what it would look like. You have group A again with treatment 1 and then gets observed, and then group B with treatment 2, which gets observed. Okay, so you have two groups. The first group gets one kind of treatment, the second gets another kind of treatment, and they both get the same test after it's done. So let's say you had the fractions example again. You have, fourth grade class with this particular teacher has, one method of teaching fractions. Then teacher number 2 has a different way of teaching fractions. And at the end, they both have to take the statewide test at the end of the year. So then you get to compare the two fourth grade classes on the same test and see which class did better. So here's another example of this. So two classrooms of fifth graders are receiving instruction using different reading methods. So their state test scores in reading are compared at the end of the year, just like I said with the fractions example. Okay. Now let's also look at the pre-test, post-test control group design. So here you have group A that gets some sort of observation and then a treatment and then another observation. And then group B, which gets an observation, no treatment, and then another observation. So two groups both get the same two tests, but the experimental group gets some sort of support or intervention or treatment between the tests, while the control group does not. So let's look at an example of this. So with two classes of kindergartners, both are formally observed for their behavior. Then one group gets some special treats or candy, okay, for their good behavior, some sort of token economy type of a thing. And then the behavior of both of those classes is again observed. So again, you see one group gets the candy or some special treat, and the other does not. So the control group is the group that does not get anything. So here now, if you're thinking about comparison group, you have the two different classrooms again. They both get the tests before and after treatment, but they both get different kinds of treatment. So in this case, with the kindergartners, both of them got different kinds of candy, maybe, or different kinds of special treats, so that we can see, which treats or which token economy was more helpful for these kindergartners to score better on their tests or do better in class. So another example of this would be comparing two methods of counseling. So two existing groups are, let's say, assessed, and then they receive a different kind of counseling. Maybe one group receives like cognitive behavior therapy, and then the other group receives a more traditional therapy. And at the end of counseling, they're assessed again, and you can kind of see who improved in maybe symptoms of depression and anxiety between the two groups. You can do a comparison. Okay, so let's do a quick true or false. More comparisons make a stronger, more believable design. What do you think? So if you said true, you got it right. More comparisons make a stronger, more believable design. More comparisons, group to group, post-test, pre-test, make research more believable. So let's do one more. What is the name of this design where we have group A, a treatment, 1, and then an observation? Group B, treatment 2, and an observation. Would it be non-equivalent groups, control group, post-test? Non-equivalent groups, comparison group, post-test only? Non-equivalent groups, control group, pre-test, post-test? One group, post-test only. So if you said number B, non-equivalent groups comparison group, post-test only, you got it right. So think again about this, where this O is placed, O for observation or assessment, right? So it's placed at the end, so you know that it only has a post-test. There's no test beforehand, okay? And we know that they're non-equivalent groups because we have two different kinds of treatments. And we know that there's no control group because both groups are getting some sort of treatment, okay?